So let's talk about dimensional analysis or factor label for problem solving. So there should be a green worksheet that you have that you can follow along to do this. But the whole idea of dimensional analysis and factor label is when multiplying and dividing numbers, the units must also be multiply and divide. And so we use what's called a conversion factor to help us convert our units. So our conversion factor basically is a ratio that equals 1, and it will always equal 1. So we'll have two quantities, one on top of the other, and then when you divide them out, because the quantities are the same, you're basically multiplying your original number by 1. Let's go ahead and do an example. I actually think it's easier just to do it than to try to explain it. So first of all, start off with the number that they give you. So that the number they give you here is 6 minutes. And we're going to set up a little ladder here. Okay, and I'm not going to put anything right here at this bottom space, but if it really bothers you, you can put a 1. Okay, but typically I just leave it blank. So, but there is a 1 there. So we have 6 minutes, and it says that we need to convert 6 minutes to seconds. So you need to ask yourself the question, how many minutes equal how many seconds? And so this is going to be our conversion factor. And I know that 1 minute equals 60 seconds. So there's two ways that I can make a conversion factor out of this. I can say that 60 seconds is equal to 1 minute, or I can say 1 minute is equal to 60 seconds. So both of them are called a conversion factor, and which one you use depends on what you're trying to cancel out. So let's go back to our problem down here. So we have 6 minutes and we want to cancel out minutes. I want to cancel out minutes, and to cancel out I need to put my conversion factor that has minutes here diagonally. So I will have minutes here on the top, and then I'll have minutes here on the bottom. So the conversion factor I'm going to use is this first one. So I have 1 minute equal to 60 seconds. And when I go ahead and work that out, I get 360, and my minutes cancels. And let me just take a step back. How you do the math is you take whatever's on the top, and you kind of do a zigzag pattern. Every time you go across, you multiply, and every time you go down, you divide. So I would have 6 times 60 divided by 1, and I would get 360, and the unit that's left is seconds. So this is called dimensional analysis, and this is the way that I prefer and I will teach. I am going to give you a factor label so that you can kind of compare the two. In factor label, I feel like you write more, and so you, because there's so many parentheses. So let me give you an example of that. Whoops, I went way far back. Okay, so we have, again, starting with our number, 6.0 minutes, and I'm going to put it over 1. And I'm going to multiply it by my conversion factor. So I want minutes on the bottom. They still have to be diagonal. And I know for every 1 minute, I have 60 seconds. And so this is just another way of setting it up. I don't like to set it up this way because you write more. I prefer the latter way, or the dimensional analysis. So again, minutes cancels. I'm left with 360. Okay. Excuse me. So right here, this is our conversion factor. And my conversion factor, again, it equals 1. Because 60 seconds equals 1 minute, those quantities are equal to each other. So it's just like I'm converting or multiplying my 6 minutes by 1. So the amount that I have is not changing. I'm just changing the unit. All right, let's continue on. And here's like a step-by-step how to do the factor label steps. So we have, again, you look for the number, place the number in the top left-hand corner. You determine the conversion factors. So what do you know? What equals what? You place those conversion factors so that the units will cancel diagonally. You'll cancel those units, and then you'll multiply the numbers. There's a zigzag pattern. And then again, at the end, you'll double check for math and your math units. You always want to make sure there's a unit with the number at the end. So I call it no naked numbers. So you want to make sure there's always a unit with the number. Let's go ahead and do a different problem if I can get there. All right, so let's try this first one. Go ahead and stop the tape and see if you can work it out. Okay, we're back now. So let's go ahead and work this out. So this is very similar to the one that we just did. So we have 4.5 minutes, and I want to convert it to seconds. I do know that I need to cancel out minutes. And so is there a relationship between minutes and seconds? And there is. So I'm going to put seconds here on top. And I know for every 1 minute, there are 60 seconds. So that's my conversion factor, 60 seconds over a minute. And I can go ahead and multiply this out. So 4.5 times 60. And I get 270 seconds because my minutes cancel out. Okay, follow along with me as we do question number 2. Question number 2 is a double step problem. You'll have 2 conversion factors. So let me show you how you set that up. Of course, you always start with the number that they give you. So we're going to start off with 1.7 miles. And I'm going to cancel out miles. So I'm going to put this down here. And do I need to convert it to meters? Do I know the relationship between miles and meters? And the answer is I don't. But they did give me a conversion factor right here. Okay, so I know that for every 0.62 miles, I will get 1 kilometer. So it won't give me the answer, but it's kind of the first step to my answer. So looking at this, I can cancel out miles, and I'm left with kilometers. So I need to do my second step. What do I know about kilometers and meters? I want to cancel out kilometers, so kilometers goes diagonally. So it goes here on the bottom because the other one is at the top. And what do I know about kilometers and meters? I know for every 1 kilometer, I have 1,000 meters. Conversion factors in the metric system, the larger of the two will usually be a 1, and then the other one will have a number like 100, in this case 1,000. Okay, so let's go ahead and cancel out kilometers. And now I am left with my unit as meters, and we go through and we can multiply and divide. So again, it's a zigzag pattern. So I go across, I multiply. When I go down, I divide. And then this is going across here, I'm going to multiply. And when I go down here, I'm going to divide. So in my calculator, I will put 1.7 times 1 divided by 0.62 times 1,000 divided by 1. And some calculators kind of freak out if you do it all in one step like that. So press the equal sign along the way. So I'll probably go 1.7, and times 1 is the same thing. So 1.7 divided by 0.62, and then I'll press enter. And then I will multiply by 1,000. And that will be my answer. So I get 2,742 meters as my conversion for 1.7 miles. And you should kind of just make sure it makes sense. Like if I got 0.02 meters equals 1.7 miles, that would be wrong. So I know that this is logic. It's a logical answer that I should have this many meters for that many miles. So go ahead and try question number 3 by yourself. See if you can figure it out. Okay, so I hope you stopped the video and attempted this. And then let's go ahead and we'll just do it here together and make sure you got the right answer. But you're always going to start off with the number that they give you, so 5.2 kilometers. Draw my little box. Again, if it bothers you that there's nothing in this space below, you can put a 1, but it doesn't bother me, so I just leave it blank. Let's go ahead and look at what we need to do. We need to go to kilometers to meters. And so we've already talked about this. We talked about King Hector died unexpectedly drinking chocolate milk. So we're going to go from kilometers all the way to millimeters. And so I could just move my decimal over, but let's go ahead and do it this factor label way. When we do this factor label way or unit or dimensional analysis, whatever you want to call it, you usually stop over at units and then you keep going. So on this one, I'm going to go from kilometers to meters. So I'm going to go to my base unit first, and then I'll go on and I'll do base unit to millimeters. So from meters to millimeters. And I did give you some conversion factors here that you could use, but that's kind of how you logically think through it here. So I know that kilometers and meters, kilometers is a 1, it's the bigger of the two. So for every 1 kilometer, I'm going to have 1,000 meters. Kilometers will cancel. I'm left with meters. I want to cancel out meters and change it to millimeters. Between the two, meters is bigger, so it gets the 1, and millimeters is 1,000. And you could just look at my conversion factors up here. I gave them to you. So meters cancels out. I'm left with millimeters. And now all I have to do is multiply it out. Because I just have ones here at the bottom, I really am just multiplying the numerator on the top on all of them. So 5.2 times 1,000 times 1,000, and I get 5,200,000 millimeters. And so if you really wanted to double check that, we know that we could move the decimal over 1, 2, 3, 1, 2, 3, and you can see that there's that quick way to do it. But this way, I actually feel more confident because my calculator kind of helps give me the security to figure out what it is. But either way, we can get the right answer when we convert in the metric system. Okay, so we're on the back side of that green sheet. We're going to do number 4 here together. This is using the factor label to convert with problems that have more than 1 unit. So this one has 2 units. I have 5 milligrams per milliliter. And the secret to this is how you set it up. So you want to set it up correctly. So please observe, you have 5 milligrams per means divided by milliliters. So notice that milliliters is on the bottom. Now there is a 1 right there, but I usually don't write it because it doesn't bother me, but if it does bother you, you keep the 1 there. So 5 milligrams per 1 milliliter. Let's go ahead and look at our problem. We have to go from milligrams to kilograms, and we have to go to milliliters to liters. So it doesn't matter which one we do first. For fun, let's go ahead and do the milliliters. So we have milliliters is here on the bottom, so I want to put milliliters on the top to cancel it. And what do I know about milliliters and liters? I know that liters is bigger, so it gets the 1, and I know that there's 1,000 milliliters in 1 liter. So my milliliters will cancel, and I'm left with liters, which is what I want my answer in. Let's go ahead and tackle those milligrams and kilograms. So I have milligrams here on the top. I want to put milligrams here on the bottom. And what do I know about milligrams and kilograms? Well, that seems like a really big step. So let's go from milligrams to grams. So stop over at the unit first. So the base unit. Between the two, grams is bigger. So 1 gram is equal to 1,000 milligrams. So my milligrams cancels. I'm left with grams. And now I can convert from grams to kilograms. Between the two, kilograms is bigger. So 1 kilogram is equal to 1,000 grams. And grams will cancel. And as far as my units go, I'm left with kilograms per liter. And so now I'm just left to do the math. Remember, as you go across, you divide. And anything in the denominator, you have to... Let me say that again. As you go across, you multiply, and then you divide anything that's in that numerator. So we're going to do a little zigzag. So 5 times 1,000 divided by 1 times 1 divided by 1,000 times 1 divided by 1,000. We could probably cancel one of those thousands out too, because one's on the top and one's on the bottom. So that would leave us 5 divided by 1,000, or 0.005. So here's our answer, 0.005 kilograms per liter, and that would be equal to 5 milligrams per milliliter. So, and that makes sense. Kilograms and liters are a lot bigger units than milligrams and milliliters, and so we should have a smaller number with those larger units. Okay, so work out number 5, see if you can do it all by yourself using both of these units. If you want to know the conversion factor between miles and kilometers, it's on the front side of your paper. So let's go ahead and stop the video and try this out. Okay, so we're back, and when you attempt this, you should have gotten set up something like this with 50 miles to start off with per hour. Hours is on the bottom, And I know there's a relationship between hours and minutes, so that gives me my hour to minute conversion. And then the given conversion factor of 1 kilometers is equal to every 0.62 miles. So on the test, I won't give, if there's anything weird like this, like 0.62 miles is equal to 1 kilometer, I will give that to you. But you are expected to know time, so like how many minutes are an hour, and you are expected to know all the metric systems. So knowing that there's 1,000 milliliters in a liter, for example. So anything weird like this, like 1 kilometer is equal to 0.62 miles, I will give that to you. All right, go ahead and attempt this and see if you can figure it out. So stop the tape and then we'll come back and we'll go over it. Okay, we're back now. So working this out, this is a multiple step problem. So we start off with the time, converting from hours to minutes and from minutes to seconds so that we can get our answer in seconds. And then we convert our kilometers to meters and our meters to centimeters.